Hello students, welcome to the classroom chemistry where you will find an experience of classroom teaching. And I am sure that you have noticed the new name of your channel, that is Classroom Chemistry. The previous name of this channel was Interesting Chemistry, and that name has been replaced by this Classroom Chemistry. So from today onwards, the new name of your channel will be Classroom Chemistry. Besides, you will find my videos in both languages, Hindi and English. So for the English Classroom Chemistry in English and Classroom Chemistry in Hindi. So this was the information about your channel, and today I am going to explain you the most important topic or the fundamental based topic, that is chemical bonding. So first of all, question arises that what is chemical bonding? Where do you find this chemical bonding in the chemistry? So I am going to explain about this question. As you know very well, the matter or the compounds are formed of one or various types of elements. And you also know the atoms of the elements cannot exist as an independent entity, cannot exist independently. It means the atom is unstable. Besides, there are some elements which are called noble gases, inert gases. The atom of these elements can be stable independently, so they are called as the atomic gases. So here again, in the grouping, the atoms tends to make group. So grouping is present in the atoms. When they form a group, the stability acquired by the atoms, it means the single atom is unstable and a group of atoms is stable. Again, I am saying that the atoms in a group can exist together to form a chemical species. This chemical species have its characteristic properties. And such chemical species are called these molecules. The molecule or the molecules, you can say it. So again, the chemical bonding, where do you find the chemical bonding? You will find the chemical bonding in the compounds. And what do you mean by the chemical bonding? The grouping of the atoms which is stable is called the chemical bonding. So the question arises here, the third question, that is, what is chemical bond? What is chemical bond? So I told you two things here. One, the single atom is stable and group of atoms is stable. So in this way you can say the atoms in a group can exist together. So what do you mean the stability or instability? When the atom is more reactive, so it is unstable. And when it is found in the molecule, the reactivity of the atom decreases to form when they combine to each other. The reactivity of the atoms decreases, so they acquire a stable condition. So again, now I am explaining you what is chemical bond. So this chemical bond is, you will find, you will take the example of the combining of the atoms. Suppose I take here this A and B. These are the two atoms. When they come close to each other, they will combine to form a group. They will combine to form a group. It is also so. Now question arises: why they do form group? Why do the atoms combine? What is the reason behind the combining of the atoms? What is the reason behind the grouping of the atoms? So here we have no answer, we have no explanation about the reason behind the grouping or the combining of the atoms. Only we can assume about it. When the assumption is, when these two atoms come close to other, a force is generated between them, and that force attached to each other. These atoms are attracted by this force. So this force is called as attractive force. It is only our assumption. So this force, this is an attractive force. This force is generated between two atoms, but we don't know the source of this force. Where from this force is generated, we have no explanation, we have no answer about it. But here, still I will tell you again. So here I want to tell you what is chemical bond. So this attractive force which we assumed here, this is called the chemical bond. This is called the chemical bond. Now I will define, how will you define a chemical bond? So again I told you that this attractive force is a chemical bond. So I will use some terms to define the chemical bond: the chemical species, the constituents of the chemical species. Constituents may be atoms, or these are the atoms, and ions can also form the chemical species or the molecule. So again, if I use these constituents, so you think about the atoms and ion. So now I am going to define the definition of chemical bond. So the attractive force, this attractive force which holds the various constituents together. The attractive force which holds the various constituents together in a chemical species. In a chemical species is called the chemical bond. Now again listen to me, that the attractive force which holds the various constituents in a chemical species is called the chemical bond. This was the definition. This is the definition of chemical bond. I think that you have understood about the three. Where do you find the bonding? What is chemical bonding? Grouping of the atoms is chemical bonding. Combining of the atom is the chemical bonding. Or where do you find? In the compounds. You will find the atoms tends to make a group. So in the compound, there the atoms are found in the form of groups, in the form of molecule, that is a group. So in the compound you find this chemical bonding. What is chemical bond? I have explained you. Now only there was a question. Up to now, here was the source of this force, attractive force. We have no source. We have no explanation about this force, from where this force is generated. So, okay. Now, it was in 1916. 1916, two scientists, Kossel and Lewis, they were the German scientists who worked together, and they gave the logical explanation and the satisfactory answer of this. So the source of this force, this attractive force. And first of all, they told us that in combining the atoms, in bonding the atoms, in grouping of the atoms, electron take place. Electrons takes place. This was revealed by postulated by the Kossel and Lewis approach. This is called the Kossel and Lewis approach. And again, they also tells us the significant definition or the logical definition of the valency. Previously, valency was defined as the number of atoms replaced by an atom, or the number of atoms combined with an atom is called valency. Suppose, for example, the previous valency of the hydrogen. Suppose this Na replaces one HCl from hydrogen, so the valency of sodium is 1. This calcium combines with two hydrogen to form CaS2. So the valency of calcium is 2. So from the number of hydrogen, we can define the definition of valency. So again, I am telling you on this account, the number of hydrogen replaced by an atom is called as valency. And again, second part of the valency, the number of hydrogen which can combine with the atom, with the element, is called as valency. But now they give the logical answer of this valency, definition of the valency of the atoms or the valency of the elements depends upon the electrons. Now, come to the how will you explain the Kossel and Lewis approach? I already explained you. So Kossel and Lewis studied about the elements very well, and they found the behavior of noble gases, that these noble gases are found in the atomic form, or you can say the atoms of these noble gases or these inert gases can stay independently, can exist independently. The reactivity of these inert gases atoms is very low, and the other atoms are very reactive. Then they go through the electronic configuration of the noble gases. They found all the noble gases, all the inert gases have the 8 electrons in the outermost orbits or the cell. This is 8 electrons, except helium, because helium has only one cell and the maximum capacity of the first orbit is 2. So this is also satisfied. But besides this helium, all the 5 noble gases have the 8 electrons in the outermost orbit. From this, they concluded that when any atom acquires 8 electrons in their outermost orbit, their reactivity will be decreased, and that atom will be a stable atom. So all atoms tends to acquire a stable octet, and this octet This was the Octet rule. Now they also gave a new term. This is the kernel. This is the kernel. Kernel. How can you define what is this kernel? I have given in here kernel. This is kernel. Kernel. Kernel you can define by taking the example of a coconut. When you take a coconut fruit in your hand, how will you get the eatable part of the coconut? You have to remove all the fibrous matter and all the hard wooden matter from the shell. And at last, when you remove all the hard part of that fruit, you will get the round shape, that is eatable part. This round shape of the coconut is called kernel. Now apply this idea on the atomic structure for your convenience, to make you understand. I have two diagrams, A and B. These are the A and B. This is A. This is A. This is the atomic structure of an element, and this is also the atomic structure, like a atomic structure. Can you identify that which elements represents this atomic structure? This, from how will you get? Go to the nucleus. You will find in the nucleus there are 11 protons. The proton tells us about the atomic number of the element. So there are 11 protons in this nucleus. So this atomic structure belongs to sodium, or you can say this is the structure of sodium. The atomic structure is of sodium. So sodium, you can write here the electronic configuration of the sodium 281. So in the first cell you will find 2, 8, and in the last orbit, the outermost orbit contains 1 electron. Now come to the V diagram. Come to the V diagram. Focus on it. What? Here again you find here 11 proton. 11 proton tells us that this atomic structure must be of the sodium. Again, and write the electronic configuration. Here I have 2 and 8. This one is removed from this structure. By removing this structure, the outermost orbit is also removed. So again, when the outermost orbit with its electron is removed from an atomic structure, the remaining part of that atomic structure is called the kernel. This is the remaining part. When you remove the outermost orbit, this outermost orbit is removed from this structure. So the remaining part of this atomic structure, this whole structure is called kernel. So kernel is a positive charged, and it contains nucleus and as well as these inner cells. These inner cells are also in this way. So kernel is the remaining part of the atomic structure which contains only the nucleus and the internal cell, and it is positively charged. So they gave a model, new model. That is, kernel is surrounded. This is the positive part, and this is surrounded. This kernel is surrounded by a cubic structure which has 8 corners to fulfill this, to get this stable coordinate. They assumed like that each kernel in the atom is surrounded by a cube, and this cube, the 8 corners of this cube, when occupied by the 8 electrons in all the gases, this cube is occupied with 8 electrons, so it is stable. So according to it, from here they concluded, they logically tells us that each atom tends to acquire its stable octet condition So what have to do to acquire the 8 electrons in this cube? So how will you? Only two things will be there. One thing, exchange of electrons, exchange of electron, and second, sharing of electron, sharing of electron. So by the exchange or by the transfer or by the transfer exchange of the electron or by the transformation of the electron in this way, when you come to sodium, the sodium acquires only one corner, and this barium acquires only two corners. So this fluorine has the second corner, one corner is still left unfilled. So in this way, this stable, the atom attains the stable octet by exchange of electrons. Exchange means the one atom will give an electron and second atom will accept the electron. Or by sharing, both the atom, the electrons of both the atom will share to each other to get the stable octet. In this way, when there are two forms to attain the stable octet, so the chemical bonds are of two types according to this chemical bond. So the types of the chemical bond are of two types. One is electrovalent bond and second one is covalent bond. Second one is. So again, I forget to tell you the Kossel and Lewis approach. This is also called the electronic theory of the chemical bonding. I explained you that the Lewis and Kossel was the first scientists in 1916 who told us that the electrons takes part in the chemical bonding. So their approach is called the electronic theory of the chemical bonding. According to this theory of chemical bonding, the bonding are of two types, the electrovalent and the covalent bond. Bonding may be there, hydrogen bonding, metallic bonding, and bonding by the water bond. That are different topics. But here in this topic, I will explain you, I will tell you about the electrovalent bond and the covalent bond. So again, one thing is more, what about the Lewis symbol? This is the Lewis symbol of the Lewis structure. The Lewis structure is showing the valency electrons. When we put a symbol of the and we show with the dots, 1 dot, 2, 1. Here for beryllium there are 2 dots, for boron there are 3 dots. These are the number of electrons which are present in their outermost orbit shell. These electrons are called valency electrons. And by the number of these electrons we can decide the valency of electron, and we also can decide whether the electron will take place the exchanging of the electron or whether there will take place the sharing of the electron. This was about the Lewis symbol. Now for today's video I am going to explain you only one type of the bonding, that is electrovalent bond. How will you explain? I will give you some examples of the electrovalent to make you understand. These are the examples to understand about the electrovalent bond, that how the electrovalent bonds are formed. So here first example is NaCl, second MgCl2 and third one is HCl. But before that, again I am coming to that position. This A and B, and they form a group that is AB12. Here I told you that this A and B, here is a force that attracts to each other, and we assume that force, that we don't know about the source of this here. So Kossel and Lewis explained by their Octet's rule that electrons take part in the chemical bonding. So here, how will this force is generated, this F attractive force is generated? I am telling you that this A will lose one electron, so it will be converted into the A positive, and the B will accept one electron, so it will be B. So by the transfer of the electrons, by the exchange of the electrons, one of the atoms which are going to bind with each other, one atom will lose electron and the other atom will accept the electron. The atoms which lose the electron will be converted into the positive ion, and the atom which will accept the electron will be converted into the negative ion. These are called the ion. The charged part of the atoms, the charged atoms are called as atoms. The charged group of atoms or the atoms is called ion. So these are the ions. One is positive and negative. So this positive and negative charge will attract each other. This is the source of attraction. Positive and negative charge is the source, and this force is called, what is it? When the positive and negative charge, the force is called electrostatic force. Electrostatic force. Positively charged particles when attract to each other, they generate the electrostatic force. So this was the electrostatic. Now I am coming to the example of the NaCl. First NaCl. This is it. NaCl is formed of two atoms. One is sodium and second one is chlorine. When sodium, first of all, the electronic configuration of sodium is 281. It has one electron in the outermost orbit, so it will lose one electron and to form the sodium ion. This is 281, it will lose, and this sodium ion, when the sodium atom is converted into sodium ion, the ion is stable. This atom is unstable, but this ion is stable. So if you are asked in your question, the ion is stable, sodium ion is stable, why? So you will explain that the electronic configuration of the sodium ion is 2,8. It has lost one electron, so when the outermost orbit attains the stable octet, so that's why it is stable. So again, this is stable, and again this electron was accepted. The electron which was lost by the sodium will be accepted by the chlorine, this chlorine. The electronic configuration of the chlorine is 287. So after gaining the one electron, the chlorine will be negatively charged, and this chlorine ion, and the electronic configuration of the chlorine ion will be 288. That is stable. So the chlorine ion is also stable. Both the ion, one is positively charged and second one is the negatively charged, both will attract to each other by the electrostatic force. This was the source of to generate the attractive force. This attractive force is called the chemical bond. So again, this is I think that you have understood about all. Now take the second example, that is the magnesium chloride. Magnesium chloride means the magnesium electronic configuration, the number of magnesium is 12, so the 282 is the electronic configuration of magnesium. It will lose 2 electrons to form the magnesium double positive ion. These positive or negative charge called as the ionic valency or the electrovalency of the ion. These are the electrovalency because they are shown in the positive and negative. So are the electrovalency of magnesium is 2. So because it's 2, the outermost orbit has to complete the octet state in the outermost orbit. It will lose, this magnesium will lose 2 electrons. To accept 6 electrons is impossible. So it will lose 2 electrons to form in the magnesium double positive. And in this chlorine to lose the 7 electron for a chlorine atom is impossible because the nucleus is attracting all the electrons towards. So the difficult to lose the all electron. So it will accept 1 electron easily. So here this chlorine after accepting 1 electron is to get converted into the Cl, which is here in this way. This here in this case, the magnesium loses 2 electrons. 1 chlorine accepts 1 electron. So the 2 atoms of the chlorine is required to combine with the magnesium. So here in this way I have multiplied this chlorine atom with 2, so the 2 atoms of chlorine will acquire 2 electrons of the magnesium which was given by the magnesium. So again, this is magnesium, this is chlorine, this you can show this structure, molecular structure of the magnesium to all in this way. This force are called the electrostatic force. In the same manner, now you have understood about the, I am taking the example of the aluminium fluoride, and aluminium fluoride, the atomic number of fluorine, aluminium is 13283, so it will lose 3 electrons to form the Al triple positive ion, and this was the electronic configuration of this aluminium ion, so it is stable. Now, the number of electrons is 3, so we require 3 fluorine atoms. 3 fluorine atoms to accept 3 electrons which was donated or which was lost by the aluminium. So here you will multiply this fluorine with 3. So the again 2, 7 and 2, 8. This is the structure and these are the structure. So I think that you have understood about this. Because this bonding, this electrovalent bond is formed by the formation of the ions. So these ions, these electrovalent bonds are also called as ionic bonds, and the compounds in which the ionic bond are found, the compounds called the ionic compound. So again, NaCl, NgCl to Al3, these are the ionic compound because when they are dissolved in the water, they separates in their ion, magnesium ion, chlorine ion, aluminium and fluorine, Na ion and so on. So they are called these. So this was about the chemical bonding. Please watch my videos. This was the first video about the chemical bonding. A series of videos. I will form a series of videos to make you understand. In my next video I will explain about the covalent bond. So that's all for today. For this please my efforts to make you understand, expect your subscription. So please subscribe it, like it and share to your other friends. One thing I am telling you, you didn't notice the way I try to make you understand. I have made a roadmap, a structure in this way. I have outlines of the topic. So always make your own outlines to remember that topic or the topic very well. How will you? Because whenever you go to exams, they go through the outlines and then think about how much I have remember, and again you go to your book, go to this video, and again learn about this in this way. When you revise it once or twice, your memory will be fixed and you will able to remember the topic. So that's all for today. Again, I am saying to you, please like it and share it. Thank you very much.